So going ahead, we have industry people from ESI. We have Mr. Chaitanya Kancharla. He is a from ESI. He is a lead technical engineer for system simulation at ESI India. He's primary support engineer for Scilab and simulation. He has master's degree in electrical engineering with specialization in power electronics and drives from BITS Pilani. And we have one more guest from France, from ESI itself, Hugh Author. He is a technical expert and Scilab business developer at ESI Group. He leads the global initiatives for Scilab and works with the development team and industry to improve the offerings of Scilab. His main task includes prototyping and client and research project management. He has a master's degree in engineering for aeronautic and space, major in fluid dynamics and numerical methods. So I welcome you both to the workshop, and over to you for interacting with our participants. They will be talking mostly about how Scilab can be used in industries and how Scilab can be used, uh, how it is used in industries and how our students can be benefited by learning Scilab in industries. They get placed, etc. So over to you, Chaitanya, and who author.
Thank you very much. I'll try to share my screen and I'll talk a bit about the different application of Scilab. First of all, good afternoon, everyone. Thank you very much for inviting us to this great workshop. As explained today, my goal would be to give you an overview of what does it mean to make a business with Scilab, what is possible, and what are the different applications that we are encountering working with Scilab. So just I'll start with a quick recap of what kind of business you can do with Scilab. I then will present you the kind of application we are working on in collaboration with different industrials. And at the end of my presentation, I let the floor to Chaitanya, so my colleague, who will dig a bit further into a given application I'll just introduce. So just quickly, Scilab in a nutshell, what is the value proposition we in ESI are providing around Scilab? First of all, and for, I would say, pretty much every open source software, we are, of course, providing training and support. So we have basic training, we have dedicated training, such as numerical optimization and also industrial application. And we provide support on the use of Scilab. Goal is to help people develop their application on their own, actually. And next step would be to help them maintain their application. So often people are coming with requirements to us. We are leading the development. We are leading the test phase and the release phase. And once the application has been released to the client, he is making the quality analysis and put it in production. And let's say every year, based on this application, clients come back to us saying, okay, I would like to have a correction because there are still bugs on the application, or evolutions because they have new ideas of what they can do with this application. What is interesting in this workflow with using Scilab specifically is that with an open source code, clients are owning the code, so they can contribute to the code. And that's a good thing, because on our side, if we are software architects, we on the other end are not expert in a given field. So if people are coming with capability for developing simulation code or analysis code, then they can do this and implement this in the existing application. And ESI team is really focusing on making I would say, the basics development, interfacing with libraries, and making all the development for UI and maintenance. And finally, the last step, once you've developed an application, would be to be able to share it easily. So the idea is to leverage a cloud platform. So we've developed a cloud platform within ESI, which is, I guess, complementary than the one which is already existing on Scilab.in. This one is dedicated to deploy those applications and make it easily accessible. This means actually that you can run a Scilab application on your web browser without having to install Scilab. It seems that some companies do not have the right permissions to install Scilab on their machine. So that's pretty much easier for their IT systems to use cloud platform, which also provide a mobile access, capability to deal with centralized data. So you will see I have one example here where people from around the world are sharing data in the same application, which give a global overview, global insight on the application, and also got the capability to deploy your application thanks to APIs. So what is more maybe interesting here would be the different application I can show you here. First of which is for Air Liquide. So Air Liquide is a French supplier for industrial gas. And basically they are providing gas for medical, chemical, and electronic manufacturer. And the first application I will show you is about monitoring and treatment of pipeline defect. So Air Liquide is owning pipeline in order to move gas from one point to another. And they are dealing with suppliers to inspect the pipeline and make sure that there are no defects, or when there are defects, they are known and treated. And to do so, what they would like to have is an application basically to gather good practices about how to characterize a defect and how to treat those. And what they need is basically a two-folded app. First, they need an application in order to gather all the information about the pipeline defect, an application that they actually could share with their supplier on site. Once all the data has been gathered, an expert from Air Liquide will sort the data by order of criticality, and based on this order of criticality, there will be and treatment that will be decided depending on the different characteristics of the defect. So I just put it here, some key elements about this application, which make it maybe a bit difficult to make out of Scilab, that basically the clients would like to have an Excel report based on all the defects they have, and they also need to share this application with supplier, which means that they must have a way to basically make sure that they have the same version. Same client, Air Liquide here, but another department. Here, we think that you already have a defect in your pipeline and you have a gas dispersion. And the idea of this application is to simulate how this gas dispersion can be transformed into an explosion of gas. So you have to make sure that you can manage this risk. Basically, this application is just a simulation application. So here is an example of people having expertise on a domain. People from Air Liquide have expertise on what would be the laws for dispersion and explosion of gas. And they asked us to have a graphical user interface on top of their expertise. So we are developing the UI, we are maintaining the whole application, and they can implement their own solvers, their own simulation code as they want. Another use case that I can present you here is for Leoni. So Leoni is a German manufacturer for cable and harnessing. And basically here we are dealing with a department who is making wiring system for cars and trucks. So the idea for them was to be able to leverage their knowledge, again, for design and simulation of electrical wire system, but to be able to use it within a graphical user interface and with a kind of system-based approach. So with the different blocks you can see here. And that's what you can see. This application is is a bit more complex than the other one you saw earlier. This one has Java UI. So here again, basically people from Leoni are not expert in code management. They are not expert in Java development or even in UI maintenance. So what they would like to do with us basically was to let us maintain the application, which means the Scilab engine behind and the Java UI. And based on that, be able to add new methods, new simulation tools in Scilab in order to make their tool more powerful. Another one from Applied Materials. So Applied Materials is a company for semiconductor manufacturing. I guess they have they have facilities in North America, but also in India. And those people were actually interested in making semiconductor manufacturing process exploration. So the idea behind process exploration is quite simple. That's basically machine learning with a specific technique that we call proper orthogonal decomposition. And the idea for those people was to be able to make and run design of experiment from their process with different parameters, and be able to make live visualization of how this system will behave based on the different value for the parameters. You can move actually the parameters with the sliders and see how it behaves on your system. So that's not exactly what you could see in this screen here, because it's obviously a car with a guy inside. So it's not a semiconductor case here, but it's an example. So basically you have two parameters, two sliders, and you can move those different parameters to see how it is behaving. And what is the interest of this is, first, you can actually give this application to on-site people in order for them to have an insight on how their process is behaving. But you can also use those models in order to make optimization, design optimization, I mean. So what is interesting here for this application, and it's actually the first of its kind, it's that it is able to deal with finite element data. And that was actually the first application we've made in Scilab when we actually have been, I've joined ESI, which is actually a professional provider of finite element solution. Another one, a bit out of the engineering scope, is for Quantify. So Quantify is a small startup who would like to make portfolio management and to add some smartness behind. So basically it's AI-powered portfolio management. And as you can see, what the guy would like to do with this is, again, he has knowledge about portfolio theory, and he also has ideas about where to use machine learning behind. And what he just would like to do is have a UI that could be able to connect to data provider, so fintech data provider, through APIs. So for this one, what was important actually was to have a cloud application. So as I've told you earlier, a cloud application, this one is a front end made out of JavaScript and HTML. It's a Scilab running behind with all the expertise about how to make portfolio theory and machine learning. And based on this architecture, this application is able to connect to broker website, which are providing all the data in order to make portfolio management. Another cloud app here is for Sanofi. So Sanofi is a chemical producer in France, and their problematics was that they have pretty much 120 facilities around the world, and for those facilities, it is really hard to control energy consumption due to air handling, basically, and they would like to make it smarter. And in order to reduce the costs, they decided to have something which is centralized. They would like to have an application which could be able to deal with the data from all around the world, and that every manager of the facilities all around the world can have access to the application and make the good control in order to make energy consumption. So basically here is an example of the cloud platform, the application cloud platform we've developed. It's a Scilab app which is behind. And again, it is a dedicated, actually here, dedicated UI you can see. this application is basically simulation code in order to make error handling and error handling simulation, and based on gathered data all around all the facilities. Another example, which come from France again, so ArcelorMittal, which is a steel manufacturing company. This one is a bit particular because it's not a one-shot application. I would say their goal with this was to be able to have a platform, so not an application, a platform, which could be able to deal with all the models that they were creating within ArcelorMittal, and is the use and deployment of those models. What they've done basically is that they use the open source aspect of Scilab and Xcos in order to develop their own platform. That's what you can see here. So they've developed their own platform, which is called Diabolo, on which you have the features they needed to make models management, their own libraries in order to make models controls and models visualization. And they also leverage the Scilab capabilities to connect to other systems in order to make and deploy actually more complex applications. That's what you can see here. You can maybe recognize a Qt UI. This Qt UI here is plugged to a Scilab engine behind and a model from ArcelorMittal in order to make a dedicated job of simulation. For this one, it's about CNES, so the French space agency. I won't make much presentation about this case because I guess you will have a more detailed presentation tomorrow from our friends from France. So just to say here that CNES did an amazing work here. They've developed an open source toolbox, which is called Celeste Lab, and which can be able to deal with flight dynamics and space flight dynamics. And so it's not really an industrial use case per se, but it's quite up to date. They managed to make the landing site selection for asteroid landing. Maybe you recall the mission from Rosetta in 2014 and the one led by Japan, which was called Hayabusa 2. Led in 2019. Well, the CNES was involved in both missions in order to select the good site for landing. And not taking too much time, the final case, and I led the floor to Chaitanya, is about the Aditya Auto, which is an automotive system manufacturer. And those guys were interested in electric motor design, space exploration. And I let now the floor to Chaitanya.
Thank you, Arthur. Hello, everyone. Let me start presenting my screen. Well, Arthur has currently summed up how Scilab is being used in the industry outside India and also in Europe. So he has talked about many companies, how they are using Scilab. And essentially our objective is to make simulation accessible to everyone. So now I'm going to discuss more in detail about one application of sorts, which where we have worked with one of our clients over here in India, in Bangalore. So which was about optimizing the design of the traction motor. So we'd go through what was the challenge that the customer had, how we use different ESI tools and Scilab on top of it to solve that particular challenge. So the customer that approached us for a solution was Aditya Auto. So Aditya Auto is a supplier of mechatronic systems and precision components to manufacturers like automotive companies. So they are headquartered in Bangalore, but then they have many other locations, facilities in and around the world, in India and around the world. And where we come from, Hugh, Arthur, and I, we come from a company called ESI. We also currently develop open source tools such as Scilab and OpenFOAM. So we are a leading innovator of virtual prototyping solutions. So as you can see over here, like everything from casting to sheet metal forming to crash, systems modeling, we provide solutions in all of these domains, simulation solutions in all of these domains. So we are headquartered in France, and we are present in more than 20 countries and have 1,200 high-level specialists like you, author, like for Scilab. Well, coming to the problem that we had that Aditya Auto had, was to optimize the dynamic behavior of their switch reluctance motor. And they had two things that they had to do in order to achieve this main challenge. One thing is to control the control logic optimization, and the other thing is the design parameter optimization. The what do you call the geometry parameters, how much flux density there should be, and how much number of turns, number of poles. So this sort of a thing. So they needed to come up with optimal design for their for a specific specification of the electric switch reluctance motors. And the goal was to achieve this without compromising on the efficiency. So they were monitoring three parameters. One is torque, power, and efficiency. So the objective all in all was not only do this, but also help them reduce the simulation efforts that it takes to perform these tasks, and also eventually reduce the number of prototypes. And another problem that they had, which Scilab was able to solve, was they didn't have too many experts who could use simulation tools. So they needed a user-friendly interface or an application which could enable all of these things to them. So let's see how we did it. So in the existing state of art, so they had a finite element tool, electromagnetics tool, which gave good results with high fidelity and accuracy, and captured current and torque ripples. But the problem with this was a static analysis took 3 hours and a dynamic analysis took 30 hours. So optimization is an iterative process. So you try some parameters and see how the performance is. You look at how the choice of parameters you have made end up in the performance of the motor, and then come up with an optimal design. So if one simulation is going to take 30 hours, then if there are 100 simulation runs to do, then the solution becomes unusable. So you won't be able to do optimization, and you would have to rely on methods like physical testing and things like that. So parametric study was not even possible for this kind of a thing. So what we proposed was a tool chaining approach, where we utilized the information that they already had, and also brought in some of our expertise that we have in systems modeling. And Scilab was the one which put all of this together. Like it was the front end, and then it was a piece that connected all the puzzles together. So we with the inclusion of their results, we preserved the accuracy of the model, and then we were able to use our own expertise and also enable the parametric study, which could make the optimization possible. And the only problem, like if you limit this to just this thing, was you would need an expert who could build these things for you. And that is where Scilab addressed that issue. We'll in the next slides, we'll see how we were able to address that particular issue. So as I said, the static analysis would give us flux and torque linkages that we were able to use in the systems model. And these are the, for just your information, these are the parameters that we used. So to speak, like, nominal number of turns per phase, resistance per phase. These are the control logic parameters like PWM frequency, duty cycle, etc. So these were some of the equations that we used to build that systems model. So in this systems model, these were the equations that we've used. I'm sure a lot of you are engineers and you would know how these are basic equations, so you would know how to use them. So this was the converter topology, and this is how the converter ran. And then this is the switch logic of this particular converter. So I will not go about explaining what the modes of operation are, but this is how Scilab was able to solve that particular case, where even when you do not have the simulation, like say domain system simulation expertise, where you would know how to use a tool, with the creation of this application, anybody who has the parameters would be able to fill in these parameters and run the simulation and get the results. And the best part about it is this could be deployed on cloud. So the number of people that it would reach, a simple application that it like this could reach, are numerous. Like if you need to learn a particular like say any software, then you would need to have those skills. An application like this could be used by anyone, and that is what Scilab had enabled. So it brought simulations closer to everybody in the company. So it's easy to use, could be deployed as needed.
Oh, sorry, did he got disconnected?
Yes, it seems like that.
Okay, sorry for the interruption. Maybe there is a network issue at Chaitanya's sir's end. We'll wait for him to rejoin.
Yes, basically, maybe I can take back the speech. Actually, Chaitanya was concluding on the presentation and said pretty much everything about the Aditya application. So just to say that there were a need for a graphical user interface that could be spread among others and allows engineers to access simulation more easily than going deep into either finite element simulation or system simulation.
Okay. So he was about to conclude, right? He was concluding the presentation.
Yes, I guess so.
Vinita, over to you.
Yeah, who would you want to take some questions? If
Sure.
yeah, so if any of you have any questions, please go ahead and ask.
Well, I'm pretty happy to see that Scilab application and range of application is pretty clear to everyone.
I guess so.
Super presentation. Merci beaucoup.
Merci à vous.
So participants, we encourage you to ask some questions to the speaker. We are fortunate to have him, and it is a very good experience to learn the industrial side of Scilab. So I encourage you to ask any questions.
Yeah, this is Dr. Diwari here again from BIT Misra.
Yeah, please go ahead, sir.
First of all, I'm not from the engineering background, from the mathematics department, but I have been promoting to Scilab for some 4 or 5 years. Today, actually, I saw the whole lot of applications other than numerical analysis that I was using. Today, actually, with your presentation, Mr. Garioud, Hugues, if I am pronouncing correctly, a lot of application that industry can use Scilab. So my question to you is that can we make a cell of students who can, and one person can contact the company for suggestions on which direction they can move, or you just go for a problem and solution type of approach?
So your question is, are there
open questions? Are there open questions to company from so many places, and company wants a student to be involved, and we will suggest those students who are capable enough, and they can join.
So you mean that the students as trained can join the Scilab project already?
Yeah, there are students who are in the 7th final years of their BTech or MTech courses. Can they be a part of the learning? But it's a very high-end learning that you have shown.
So I'm not sure to understand correctly your question, but I would say that the Scilab is at the moment still. I won't say that it's new in the industry. I would say that people are just considering the power they can leverage from Scilab application. So Scilab is something that industrials are learning on the go. The solution, I guess, for pretty much the pretty much people I know in Europe are learning about Scilab during their company experience. So I don't know if it answers your question on any way.
I mean, could it be possible?
Or if somebody else can ask.
Okay, Chaitanya or maybe Hugues. Could it be possible to have some internships at your ESA company for our students, maybe?
Yeah, for internship, sure, you can. So I would say you can send resumes to our local HR entity, and we could see about this. I would say that at the moment, and considering the current condition and the crisis, we might not be able to hire anyone at the moment. And as for the Scilab topic, we are currently lacking of interesting topic to make intern work on. But as soon as we have something, actually, that's something that we could share with any of you. Maybe what I will do is on the scilab.org website, I'll try to create a new section for opportunity in case we are looking for people. So you can all be aware of the topics that we are currently interested in, and maybe that we are looking for people.
So I just spoke to Chaitanya. He's trying to reconnect.
Yeah, I have a question.
I'm connected, but were you able to see any part of my presentation, or was it not shown at all?
We were able to see the last part.
Oh, from the beginning you weren't able to see, is it?
Yeah.
No, we see everything, Chaitanya, until you dropped off.
Okay. I don't know when I dropped off, so that's why I was asking the question.
You were about to conclude on the Scilab use.
Okay.
So we are now in answering questions.
Okay, all right. Thank you.
Chaitanya, if you want to conclude formally, you can please go ahead, share your screen and conclude formally.
Well, there was nothing. Since the last slide, what I wanted to say was, like, we'd be open to we'd be open to taking opinions on how to make Scilab better from everybody, from the academia as well. So if you have any thoughts on how we can improve the Scilab offering, please do let us know. And our team will see how they can include it in their roadmap to improve the product. So that was the thing. And all in all, as I said, like, we offer training, consulting, support, and services. And it's as a company. But then you see that in the presentation that Hugues and I have shared, a lot of industry uses Scilab, and the training that you are going through right now, and eventually as you improve in Scilab, there'd be a lot of opportunities that will be available for you. It is a skill set that is definitely appreciated in a lot of companies that I know. Applied Materials, Ashok Leland, and Aditya Auto, one of the use cases that I talked about. Several other companies use Bajaj. There are a lot of companies that use Scilab. So that's the point I wanted to conclude on. So thanks for letting me do that.
But what are the other skill set required? Other than Scilab?
You would obviously your engineering expertise, of course, and then on top of that, knowing a particular tool or how to use a particular tool would also can also improve your chances to be employable. So, and it being Scilab being an open source tool, and it being a versatile tool, so it could be used in any engineering domain. And if you have the expertise of how to know the tool, it would only increase the chances of being able to apply that knowledge in the industry.
I see a more generic question on the chat about working with open source software such as Scilab. I would say that it's obviously a benefit to be able to work with open source software, as people in the industry are tending to reduce more and more the costs about the software part. That's really a goal of IT systems within industry to reduce the cost. So if people are able to work with open source software, and there are actually a lot of powerful open source software, such as OpenFOAM for fluid dynamics, such as Scilab, Python for different kind of application actually. So yes, it's obviously a force for people to be able to deal with that kind of software. Then I see another question, which is, can it handle the complexities like we have in COMSOL? So I'm not sure to understand the question here, because I guess COMSOL is multi-physics software simulation, I guess. So what kind of complexities are you speaking about?
Like coupling of partial differential equation. Since maintenant je suis étudiant master à la IIT Madras. So so I have to handle the complexities of the partial differential equation, like coupling of pressure with the velocity. So is it applicable with the Scilab?
So Scilab is just an easy way to set up numerical application. As soon as you have equations, you can make pretty much everything you want with this. I just will say that there might not be any pre-implemented tools in order to make PDE solving directly. You've got capabilities to make ODE solving, but PDE solving should be implemented through a finite element solving process, I guess.
Okay, because I generally have problem with the hyperbolic term while solving the equation. Parabolic is easier to solve using finite difference or finite volume, but but hyperbolic term is not easily solvable, like we have in COMSOL while we do the coupling. So that was my doubt actually.
So here I would say you have way more expertise than I have in the domain. Again, if there is a numerical method to be able to deal with those hyperbolic terms, then it is obviously easily implementable within Scilab. But there is no already implemented tools that could allow you to make this quickly.
Oui, ça va. J'ai compris. Merci beaucoup.
Avec plaisir.
So we are at the end. I think no more questions are there. So thank you from the ESI people to just come here and motivate everyone that everything is used in industry. Also, even the open source softwares are used in industry. So great to have you both. Thank you so much.
Thank you very much for the invitation.
Thank you. Yeah, you guys have a nice day. Bye.
Bye-bye. Bye. So to all the participants, I have posted, even Preeti has posted the attendance, and please mark your attendance for today's day, and we'll see you tomorrow. Please practice. If you have not finished practicing your problem, the practice problem, if you have not finished, please do it overnight. If you have any doubts, we'll start tomorrow at 9:30 to 10. That's an optional session. Those who have doubts in the practice problem can join that session from the same link, and we'll be happy to help you to solve those problems. So if anyone has any questions on textbook companion and lab migration, which we didn't do, you're welcome. We can answer that.
Also, participants who had difficulty installing toolboxes should also join early tomorrow.
Yeah, can join at 9:30 tomorrow, and we'll help you with that.
Yeah, we'll help you with that.
Or you can drop us a mail. We can help you over the email also. I'll put the mail on the chat box. It is contact@scilab.in. If you can post the screenshot of the error you get while installing, it will help us more. So I guess we can wind up the session. If no more questions or queries are there, we have to meet tomorrow again.
I would like to say that tomorrow there is one live session on graphical user interface. All of you, please make sure that you have installed the toolbox, GUI toolbox. And if not, then please come at 9:30. We will help you out with the installation part.
Excuse me, ma'am. This is GUI Builder is
Yes.
or something else? Means
GUI Builder Toolbox. That is
Okay.
correct.
Okay.
Ma'am, one thing I wanted to ask that the schedule for tomorrow is same as we have got in email, or is there any change?
I'll ping you the link of the schedule here. It is the same.
Okay.
There is no change. But still, I'll ping the schedule link here in the chat box.
It's a live document, right?
Yes, it's a live document. So I've put the schedule. You can check it once, the link for the schedule. Okay. So see you all tomorrow. Bye.
And I would like to say thank you all. Nicely, timely being there and handling it so well. Thank you all from
Thank
my
you so much, sir. Thank you so much. We appreciate it. Anything else? Anyone wants to? Any questions? Anything? We can wind up. Okay. Bye. Good night.
Thank you all for coming. Please
Thank
join
you.
tomorrow with the same enthusiasm. We look forward to you. Thank you. Goodbye.
Yes. Thank you, everyone.